You're listening to the Effective Statistician Podcast, the weekly podcast with Alexander Schacht, Benjamin Pieske, and Sam Gardner, designed to help you reach your potential, lead great science, and serve patients without becoming overwhelmed by work. Today we are talking about animations and movements and how to use them effectively with data visualization. Today's guest is someone that is really awesome. She has so much knowledge about data visualization. She has worked with world-class institutions like MIT and helped even the BBC with her work in showing better the data and making sure that everybody can understand data, for example, around elections or around the corona crisis. So listen to this episode, you'll get a lot out of it. There's also the PSI conference coming up, and she's also speaking there. So look up for the PSI conference and check for Irene de la Torre Arenas. You can find all the complete name in the show notes and check that out. I'm also speaking at the PSI conference, and so you still have time to register for it. It's completely virtual and it has lots of great content. There's not just presentations, but there is also lots of social interactions. So check that out. If you then want to become a member, which you will be if you attend the PSI conference, then you can find all of that, including much more activities at psiweb.org to learn what PSI does and why it may make sense to not only register for the conference, but become a PSI member and check out all the other things that is coming there. Welcome to another episode. Today I'm talking with Irene. How are you doing this morning?
I'm good, thank you. How are you?
Very good. I'm quite excited about the topic today because it has been something I'm experimenting with for quite some time, and now I'm really glad to have someone on the podcast that is actually an expert in it. And that is how to use motions and animations in your data visualization. So tell me a little bit, how did you come to think about this topic?
Yeah, so I was doing my master thesis and I was finding topics, and at the beginning I wanted to do it about how charts lie. And my advisor told me, no, don't do that. There are too many research about that. Let it go. And he mentioned doing something around motion animations, etc. And it wasn't supposed to be a taxonomy. It was just going to be an exploration of what you can do. But while I was doing the state of the art and kind of going through all these amazing projects, I'm kind of an organization obsessed. I really like everything to have kind of a specific order and cluster things that have specific things that are similar between each other. So I ended up doing these groups among the projects that I was seeing what are the things that or the characteristics that they have in common. And by the end of writing the state of the art, I had a taxonomy of how to use motion in data visualization. And the funny thing is that I thought that it was just one thing, a master thesis, you finish it and then you never come back to it. That's a lie. It has come back to me quite often, and I use it very often now. And every time that I have to use these implementations, I think, okay, what about the thesis? What is it that I saw here? Does this actually fit in what you were thinking? And most of the times it does. So yeah.
Was there any particular data visualization that was animated or that had motion in it that inspired you to work on this topic?
There were a few. One of them is We Feel Fine. It's a visualization from 2005 or 2006. And let's see if I remember everything. They collected posts from Blogger, from the blog site platform of Google, and they analyzed how people felt, if they were happy, if they were sad, etc. And I didn't know about this project. My advisor told me about it, and it's full of colors, it's full of movement. It really tells you how people are feeling. And right now, I don't think you can even access it. It's quite old in the internet age. It's not old. And it used, I'm not sure if it used Java or Flash, but I remember having problems to see it 5 years ago. But it was fascinating to see. It was just so beautiful, right? So that was one. It was actually the first project that came to my mind when you made that question. So that says something. The other project was done by my advisor, Pedro Cruz. It's about traffic in Lisbon. So he used a metaphor of kind of a heart, right? So if there's too much traffic, the cars cluster the heart, it's hard to breathe, it's hard to move along. And if the traffic is okay and you can circulate in the roads, then it's a healthy heart, right? And it is also very, very beautiful. He, in particular, Pedro, he's just an amazing designer, visualizer. I would totally recommend checking his work because it's really, really inspiring.
Yeah, by the way, we'll put lots of show notes into this episode because obviously you can't see what we are talking about. So check out theeffectivestatistician.com, find this episode with Irene, and then, check all the links to these amazing data visualizations. For me, actually, one of the most inspiring data visualizations in that regard is Hans Rosling's presentation, where you see the health and the wealth of nations developing over the 20th century, and how there's overall actually a very, very good movement from, very poor, dying very young, into an area where people are, or nations are rather rich and live quite long. And of course, you can see then over the century kind of, World War II, for example, or you can see the HIV epidemic, especially in Africa. And you can see how, certain events had an impact on certain countries. Yeah, so certain bigger political events. And that's really, really fascinating to see. But it tells this very amazing story of how the world is developing. It's an awesome 4-minute video done together with the BBC. And that inspired me to kind of think about how can we use this effectively in clinical research and beyond.
Yeah, I think Gapminder is an incredible example of what transitions to your chart if you're using it in a good way. And it has become now such a symbol. It's not only a video now, then it was moved into an interactive chart, and now it's a whole platform about how the world is improving through time, and you can play around. But the original Gapminder, so that scatter plot, it is there, and every time that I play it, it is really interesting.
Yeah, you can always kind of look at it again and again and again, and you see kind of smaller stories in the bigger story. If you have a book and that has, this main story part, but, there's these little stories in this love story or the story of a friendship and so on. And the same you see in these really amazing visualizations, these stories of individual countries, for example, for Gapminder or for special, specific historic events. So yeah, it's really, really interesting. And I had something similar when I first applied it to some data myself, that I was seeing that physicians who were looking into the data also were looking at it again and again and said, every time I look at it, there's something new I see in there. So it's really fascinating. Okay, so how can we actually use motion and movement into our charts. What are the different aspects there? First, how does it separate from other aspects in data visualization more generally?
Mm-hmm. So one of the things that I thought about starting this research is usually designers kind of distrust animations, especially if we think in a normal context like a PowerPoint, right? You say, I don't want to add this. But it's a very, very effective implementation. It's actually one of the things along color, orientation, size, stereoscopic depth. So if something is further away from us or if it's blurrier, etc., that really catches our eye, especially if it's in the corner, in the peripheral vision. And I think it's just biology is something that we use for knowing if we are safe or if there's an animal around that wants to eat us. So of course, now we are in a safer environment, but that still works. It's very effective to our eye, and we use it for our charts, right? So we use color to highlight or to differentiate categories. We use orientation, especially for indicating, I don't know, flows or Sankey's, for example. We use size, etc. So we employ these attributes in our data visualization, but usually motion and transitions tend to happen as the last thing that we add on, as something that is nice to have. And the main problem is when we do that without really thinking, okay, what is what I want to accomplish with this implementation here? What I want this animation to do in my overall design? So that's when I started doing this categorization. What are the functions that the motions are doing in the visualizations? And what I basically found out is that there are 4 ways of using this in an effective way. And of course, it can go wrong really easily, like with anything, especially in design. But they tend to be quite interesting. So the first one is, it's probably the most straightforward for me, which is data that is portrayed as motion, because it's basically motion. It's per se. So think about.
Can you give an example for that?
Think about visualizations where we are showing traffic flows or movements or weather changes. So there's this amazing visualization, the wind map, that shows currents of air in the United States, and it shows you the flow, what is the orientation, the speed, etc. That visualization actually influenced another designer to do a very famous visualization tool called Earth, which is just the planet Earth, and you can see the wind currents, you can see sea currents, temperature, etc. And from there, you can now see how wind is portrayed in the weather section of TV news in such a way, because it's very effective. You see it very well where the wind is coming from, if it's strong, if it's slow, etc. So it's basically.
So this is really when you have time as a variable in your data set. So, and then you use kind of that time to kind of also portray it in your movie, and and you can have it speeded up or slowed down or different ways of showing it.
Yeah. It can be done in 2 ways. So if the data has position and time, then it's kind of display movement. That is a traffic flow that we were talking about. If it only has time and we want to use it as a metaphor, then it can be encoded in an indirect way. So I'm trying to think about a project that I did about coronavirus, where we use a metaphor of a flower, and it was showing how coronavirus cases and deaths changed through time. And we have obviously data for every day. And it was a metaphorical flower for everyone that was kind of suffering through this whole pandemic. Obviously, that's not movement, but there's an animation in there. And we use it as a way to explain that cases are rising really fast, or that are happening also very fast or not. So it's something that has to be related to time. But it's also true that you can use this type of information without the data having time. So imagine that you want to show, I don't know, I'm going to use another project of mine, corruption in the different states of America. And you want to kind of encode that the more corruption, the more difficult it is to see something, or the more barriers you have in order to find the specific information. You can use it by encoding corruption into a visual shape that has motion there, so an animation, and then that's not related to time, is not related to movement per se, but you're using an animation to explain that there's something there that is avoiding you to get what you want.
Yeah, I think that is similar to a project where I was looking into, and we had disease severity as kind of the variable which we encoded with motion. Because we were thinking kind of, okay, for that, it was a progressive chronic disease. And so over time, you will deteriorate. Yeah. Continually, of course, it goes ups and downs. Yeah. But you can think of yourself as, well, you start with mild symptoms. It was Alzheimer. Yeah, you start with mild symptoms, and you progress over time, and then the more you progress, yeah, you see how different parts of your cognitive space are affected. Yeah, so memory, cognition, ultimately speech. Yeah, and so you could use there, instead of time as a variable, used overall severity. Mm-hmm. And I think that's in the same way here. You used kind of in the flower example, you have number of cases, yeah, worldwide or within a specific country. There was one piece in this flower that I found really, really nice, is that you had the, so to say, the face of the flower as this round circle. And then there are, like a clock that goes around there. You had these different visualizations that shows it. And I thought that kind of similarity with the analog clock is really a nice way to visualize time and to kind of show that, especially if you have something like a day or year or something, more periodic.
Mm-hmm. Yeah, that flower actually took a long time to finalize. It's just a timeline, right? It's a radial timeline. And the initial, so what I'm going to explain a little bit for people who might not know what the project is about. So again, it's about coronavirus, and this metaphorical flower has different parts. So the tail, the stem, sorry, it basically grows as a cumulative cases in a country or in the world grows. And then the petals are people who have died of coronavirus in a specific day. So you basically see the flower growing through time, and it becomes kind of beautiful. It's really sad when you realize what the data is about, and that's the whole point of the project. But it basically, the petals create a radial timeline of how many people have died through the last 6 months. I think the data we published it in December, so it was 6 months of the pandemic. And it's quite interesting for me. That timeline was quite interesting first because you really can see the different waves coming through the continents, the countries, etc. But it also showed quite well, I'm gonna say, blobs. Yeah. So issues with the data. For example, I'm Spanish, so one of the first flowers that I really wanted to see is Spain. And what happened there is that in June, the country decided to change how they were counting the number of deaths. So they didn't publish data for a while they were kind of constructing this new, or collecting all the data they needed for this new way of counting. And then by the end of July, they publish in one day, I don't know how many deaths, 1,000. So you get this huge petal, and then the flower continues normally. But it's really interesting to see kind of these issues with the data in such a way, because then you really see where something happened with the counting. And it makes, again, the flowers quite unique. And I feel very weird speaking about it in this tone, because it's a really sad data set.
Yeah. What I also like about this with the petals is that you kind of see what happened. Yeah. So I think that is one of the parts with movement is kind of you only see at a given moment that part. Yeah. So if you think back about the gapminder thing, yeah, at any given time point, you can only see where the nation's now. You don't you need to remember where they started. But here with these petals, you still see kind of the past timeline, and so it's a nice additional feature in there that helps you to see it as animated, but also still the kind of timeline. And I've seen that sometimes in graphs where they, you have just a regular line chart, yeah, and you have time in the study, and then they show, okay, first kind of what happens up to week 2, what happens up to week 6, what happens up to week 12, and then what happens up to 1 year. Yeah. And so it's animated in that way and helps with the storytelling, but it kind of still is, this animation, and you see what happened up to that time point.
Yeah, and that links to the second type of motion in this taxonomy, which is interpolation of values, right? So when our data is not very granular, when we have clinical studies that have happened through a week, we don't have data of every single day sometimes, but we still want to have a general idea. And if we use animation at the end, what we do is connect these weeks through an interpolation, and then we see how the chart kind of changes through time. Gapminder is that we don't have data for every single day of every single year. It's just that when we animate the years in our animation, they are connected. There's kind of an algorithm that says, okay, your starting position is X and you need to go to Y. Let's calculate what happens in between. And we actually do that in PowerPoint quite often, right? When we want to move things. So it's something that we do very often, and we see very often the bar chart races is just exactly that. So one of the problems with motion that you were mentioning before is that you need to pay attention. The moment you kind of move your eyes, you're missing part of the story. So it needs to be very engaging. It needs to be easy to follow, easy to understand. Then also think about, okay, what is the final image that I'm giving? Because the other points are missing. The only points only last for a second, let's say. So it's something that is a cognitive kind of effort because you need to be watching in order to get all the information.
Actually, that's also what I found to be really difficult, to find the right speed of the animation. Yeah. We put a lot of effort into kind of, having it faster, having it slower, maybe even have pauses in it. Yeah, so that people could see what is happening at a specific time point for a longer time, or maybe, at that point then have some kind of text appearing so that people can see it. What's your experience in that regard?
So I didn't think about it much while I was doing this thesis. So giving the power to the user to stop, let's say, to control the animation. But it was something very, very important when I was working at the BBC. So it's an accessibility rule to let users control a video, to let users stop an animation, etc. Especially because there's people who have motion issues, so they might actually get very, very dizzy when watching an animation. So it's important to think about these things. And right now, my advice would be allow the user to stop, allow the user to pause, allow the user to restart or go to the end. So really give the power to the user for them to control whatever is happening in the screen.
Yeah, that's very good. Have some kind of default settings that you can then alter. And I very much like the kind of, fast forward, fast backward kind of stuff that we use, at least that I know from the tapes that I was using decades ago.
Yeah.
Okay.
I use tapes too. That's the video behavior, right? That's what video do, and It's something that we might have forgotten while doing cool stuff in internet, and then we thought, there's something missing here, and it's the control.
Yeah. What's the third way, the third taxonomy?
Yeah, I would say that that's one of the most important ones, which is motion as a storytelling device. It has a very, very nice name. It's one of my favorites. It's basically using animations and transitions to explain to the user what's happening in the screen. So it's not only in a scrolly telling kind of allowing the user to interact with whatever the animation is doing, but it's also if we are doing, for example, a Shiny app, and we are interacting with, we are zooming in or zooming out, or we are selecting a specific data sets and the chart changes, it's all the transitions that we should implement in order to tell the user, be careful, be aware, just by interacting with the data, you're modifying the chart. So the scales are changing, the way you're displaying or sorting the data is also changing. You might be just zooming in into a specific attribute and highlighting it instead of the other ones, right? So these are all the design cues that we use to tell the user the chart has changed because you have interacted with it. And it might sound superfluous, but I think it's really, really important, especially with charts that in which the interaction changes the scale and the axis.
Yeah, that's nice. So, for example, that when you change from a linear scale to a logarithmic scale, it's not just a click, but it kind of transitions, and you see, how the curve is changing. Yeah, so how, for example, an exponential curve becomes a linear curve on a logarithmic scale, things like that. So, yeah.
Yeah, because I think if you don't add that, you might lose it, especially when the lines might be very close together because it's just the number changing, the position of the lines are still the same. Then you won't notice it at all. So, and it's an important information that you're changing the range of your axis when when, especially if you're analyzing the data. So I think it's a very interesting use of motion that we should think about more and more if we do more dashboards and if we do more interactive visualizations that allow the user to interact with the chart.
I think it also makes it much easier to see what is exactly happening. So I'm just thinking about if you have a scatter plot on a linear scale and you change it to a logarithmic scale, and it just kind of goes from a millisecond from one to another. You don't see how these individual points are moving. You just see before and after. But if you have this transition, you can actually see, okay, these groups of points here, they move to here. And that group here stayed more or less there. Yeah. And so you don't see that if you have just two pictures.
Yeah, you're right. I think it's telling you exactly what is happening. So it's also very engaging. I think again, this goes back to the beginning. So motion really catches our eye, and if we do this, it's not only giving information, but it is making something a little bit nicer.
Yeah, and you also don't get lost. I'm just thinking of a map. Yeah, and with if you use Google Maps or something like this, you zoom in, and it's not just a click that you kind of from one moment to the other you're really, really close in the map, but it zooms in, and therefore you can really kind of see, okay, this is now the smaller part of this bigger part. I know exactly kind of where it was oriented on the less granular map, and so that makes it really, really easy to see kind of, okay, where's it coming?
Yeah, especially for areas that you don't know where they are. So if you're seeing a map, for example, in Germany, since we both are here, and you want to zoom into, for example, I don't know, a city that is an outlier, or you want to find a specific thing, but you don't know the the location, let's say you could write it in search, and then you click and you zoom in into that area, right? If there's no animation and you don't know where that specific area is, then you don't really know where it is. So actually the motion and the zooming in is telling you, okay, this place is located in this specific place. So it's giving you information too.
Yeah, so really kind of you see first the map of Germany and then it zooms into Munich or it zooms into Castrop-Rauxel, which you probably don't know where it is if you're not from Germany.
Yeah, and that's basically what the scrollies, these scrollies that we see so often do, right? They guide you and they use motion kind of like telling you a general view, then you zoom in, then you do something different. And it's really what movies do at the end of the day. So when we think about these implementations, it's also good to kind of do small storyboards and think about, okay, what is the story? What do I want to do? How do I use it?
Yeah, that's a very good point. It's very similar to techniques that you see in movies, where also kind of they zoom in instead of kind of just making a new take, and that way you can see that it's a part of a bigger picture. Yeah. Okay, what's the last taxonomy that we need to speak about?
Yeah, so the last one is the shiniest one. It's called motion as a captivator. So it's that type of motion that is not data, is not an interpolation, and is not used to guide you through the visualization, but it's still very, very interesting, very nice to see, and it actually is what drags you to the visualization and lets you stay with it. So my thinking was, there's so many implementations of motion where there's no supposed value on it, but because of it catches your attention, and then once you've realized what you're seeing, it looks interesting, so you stay with it. The ideal situation would be that this type of motion is used alongside another one, so that data's motion is also captivating, that interpolations are also very nice to see. I think a Minder is a really good example of how captivating and how aesthetically pleasing animations can be. And then also if used well, motion as a storytelling can also be very interesting to see and be very pleasing to the eye. It was during my thesis, I also researched about aesthetics, and it was very interesting because there's actually mathematical formulas that try to calculate when something is beautiful. And at the end of the day, the thing that I like it the most, and is the thing that I'm going to explain, is that there's a formula that says that there's a balance between complexity and easy to understand, and motion fits into this quite well. So if this implementation is very complex, but it's actually helping you to understand what you're seeing, then it's a good use of motion. If these animations are very shiny, very fancy, and it catches your eye, but it doesn't give you anything back, then that's not a good use of motion, and you will actually frustrate the viewer. So don't do that.
Yeah. So it needs to be, I think that's interesting. So to see beauty, aesthetic as a function in itself, because it attracts the people, and I'm pretty sure it also makes things easier to memorize. But is it?
There's a very, very interesting research by Michelle Borkins, and I was actually reading it this week for a workshop. And her first research in 2013 showed that people tend to remember things that have photographs, icons, things that really relate to us much better than just abstract charts. And especially people tend to remember charts that tend to be different to what they see every day. So bar charts and line charts, even though they're very useful, they are not remembered that well because we are surrounded by them. this was kind of problematic regarding the chart junk of Tufte. So in 2015, she did another research about memorability and efficacy. So how can we make a chart not only memorable, but also in a way that we remember the message that the chart is displaying? Because we might remember an infographic, but we don't really remember the whole point of the infographic. And it was very interesting because some of the charts actually improve if they have labels, if they have numbers, if they have titles. But the whole point of this is sometimes we are scared of doing things differently because people are not used to them. But that's also a good way of attracting them to what we are doing. The key is that even if it's something that is complicated, that is not traditional, the key is test it and make it as understandable and accessible as possible, so that first you catch their attention, and then once they are seeing it, they understand it and they like it and they get the message.
Yeah, I can completely relate to that. I was once sitting at a conference and it was about medical data, and there were lots of clinical studies shown, and most of them had pretty much the same design. And so I was seeing the same bar charts, the same line graphs again and again and again and again, even on the same variables, just different studies. And in the end, you don't really remember, okay, what was the real outcome here? Yeah, because you had the feeling like, well, there was just another line chart with different colors, but I don't remember it. Whereas if you can think back about the Gapminder examples that we had at the beginning, yeah, it's not only interesting data, it's also beautiful data. The whole setup, how he stands behind this transparent screen that looks like it's hanging in thin air, really kind of this Star Trek kind of atmosphere, but in this loft environment. It's really, really nice and beautiful as well. And I think that has really a feature in it, yeah, so that you can remember it, that there's some more kind of emotional attachment to it. And if you get the emotions involved, then people will remember the facts much better. Yeah,
I completely agree. It's a difficult thing because you still want to use the same chart if you're comparing results, right? You don't want to be changing it in every slide. But one of the things that we did at the MIT Sensible City Lab was, okay, so the figures in the research paper are the traditional ones, but then let's complement it with a page that explains this data in a different way, that is really using the full power of visualization and the combination with the latest techniques. And it's really effective because you at least for me, obviously I think I'm trained for this, so I don't remember the figures, but I remember the visualizations.
Yeah, and so it's not a either or, doing both.
It's both. Yeah.
Very good. Awesome. So we talked quite a lot now about animations and movements and what you can do with it. We had lots of examples that we'll refer to in the show notes. So make sure to go to theeffectivestatistician.com and find Irene's episode here. And we looked through these different taxonomies, how you can use visualization. And you can combine these into one, but try it out. Yeah. Especially with the different software that is out there. There's lots of kind of off-the-shelf software. There's, things like you can try out in Flourish, for example. There's, this bar race that we talked about. There's GG Animate that you can use in art to animate stuff. So have a try. Also, we had on the wonderful Wednesday of the special interest group, we have a couple of different examples where we had the typical clinical data sets, but we have animations in it, or some movements in it. And so also check out these webinars, and the corresponding blog will also link to that in the show notes. So thanks so much, Irina, for this awesome episode. Any final thoughts that you would like to have the listener as a key takeaway?
I would repeat what you said. Try it out. This is all learned by practice, and then also show it to people. So test it, because sometimes we do really cool things, and that has happened to me, and then no one understands it, which is not really what we want. But try it out and do it, and have fun with it. I think that's the best part of it.
Yeah. Thanks so much. And talk to you soon. There will be more episodes coming with Irina, so stay tuned for more great stuff here. This show was created in association with PSI, and check out the upcoming conference at psiweb.org. Thanks to Rain, who helps with the show in the background, and thank you for listening. Head over to theeffectivestatistician.com, where you find the show notes with all the links that we talked about. Reach your potential, lead great science, and serve patients. Just be an effective statistician.